Hi, everybody. That work? Ah, that's good. Still can mic flip. Thank you for coming this early in the morning to an agricultural university in the middle of damn nowhere. Beautiful area. I've never been to Plovdiv, and I like it. I really do. I like these trees too. Should we name them? What should we call this one? Mr. Fuzzy. This one, Conesies. Well, it's been 2 years since we launched Cardano. It creeps up on you like having kids or something like that. You say, only yesterday did we conceive of it. Cardano started as a project in 2015. And it started with real high aspirations. The model that we chose to follow was something like a DARPA program. And so we said, let's go pick a very risky, big, sexy, juicy, huge problem. And let's just do lots of science, high risk, high return science. And let's see where it takes us. And then somewhere along the way, let's try to trim it down, winnow it to a point where we can actually build a product to commercialize it. So for example, many of you may not be familiar with a project called Halo, but you're probably familiar with something called Siri. If you have an iPhone, you got Siri. Well, it came from a project just like that. In 2003, they said, let's build this AI that just lives with you, lives in your laptop, lives on your phone. You can have a conversation with it. It can organize your life. And of course, they didn't achieve that, but they wrote a hell of a lot of papers. They learned a lot along the way, and it launched the entire field of cognitive assistance. Now we have Alexa, Cortana, and so forth. So analogously, back in 2015, we asked, what would it take to build a financial operating system for the world? Something that has billions of users, the fees always go down, it becomes more and more open, more and more capable, more and more programmable. It was a very big question. And we decomposed that into 3 areas of inquiry. One was scalability. We said, well, if we're going to have billions of people, the system should get faster, or at least stay at the same performance, regardless of how many people are using it. Common sense, okay. Second, we said, well, this system is going to be connecting to every country's financial infrastructure. It's going to be connecting to thousands of corporations and private industry. So it needs to be interoperable with everything, right? Okay, common sense there. Could you imagine a world where Wi-Fi was connected only to the manufacturer of your phone, so your phone could only connect to Samsung routers or Apple routers? It wouldn't work. The whole reason the standard works is because you can connect to all of them, regardless of where it comes from. And so we need to achieve that for the movement of value and information. And then finally, the problem with products and the beauty of products is they tend to be connected to custodians, to brands, to people who run them, whether it be a committee or it be an individual or it be a corporation. For example, Windows is controlled by Microsoft. The iPhone is controlled by Apple. Android mostly controlled by Google. But when you remove the custodian, who controls the product? We have some examples, like Linux, for example, but even then, it still has some centralization. But these protocols are supposed to be decentralized, and by definition that means no one's in charge. No one can decide unilaterally. So how do you build a sustainable system when it's not clear who pays and who decides the future? So these were the 3 inquiries that we figured that if we did substantive research in, we would be able to make substantial progress towards that goal of building a world financial operating system. Okay, that's where we started in 2015. And we began with lots of research. First, we had to find some scientists that were crazy enough to go down this road with us, because we're like, wow, are we actually going to be able to write papers? Can we publish them? Will we get into conferences? These were all open questions, and it took a little while to prime that pump, but boy, did we. We set up research lab after research lab, one in Scotland, one in Greece, one in Japan, And we ended up writing more than 40 papers, and we learned enormous amounts along the way. You see, we were very much in a first principles mindset. We didn't take positions. We didn't say Bitcoin was right or Swift was right. We didn't say proof of work or proof of stake or any of these things. We just asked things like, what is a blockchain? Mathematically, what is it? What is this ledger? What is an authenticated data structure? What is consensus? What is privacy? What should an asset look like? What should a smart contract look like? What is a transaction? Where should transactions live? How should these things be stored? Very first principles questions. Because why not? It's a high risk, high return project, and we had the luxury of having great scientists to sit down and dream up and imagine really good definitions for these things and give us a way of kind of thinking about them. And 2 years later, after lots of science, lots of papers, lots of deep thought, we got to a position where we could go from aspirational to functional, to something real. So we began a process of slowly but surely building Cardano. Then we had to make some decisions. How do we build it? What techniques and methodologies do we want to use? Do we want to also innovate there, or do we want to just de-risk that and do something simple, like build it in Java or JavaScript? And I said, you know, the point of what we're trying to do is to build something that lasts, so we made a decision to follow an approach called formal methods. This was a controversial decision. It certainly cost us a lot of time, effort, money, and slowed us down a little bit, and we had to learn a lot along the way. But the power of formal methods is that it gives you a way of connecting what you want to do with what you've actually done and prove that it actually works. It's correct. Just that simple. And how do you prove it? Through the power of mathematics. Turns out, long before we had the hipsters in the coffee shop writing JavaScript, long before we had the neckbeards writing C code, long before we had even the first programmers, there were mathematicians. And all of computer science came from that well. And those people thought about things in a much more rigorous way. And everything was a proof. Every program was basically rigorous. And it turns out that the people who thought that way never went away. They built all these tools and techniques which are now used in the aerospace industry, the health industry, places where if the code fails, people die, the plane falls out of the sky, your X-ray suddenly is a little bit too radioactive for you, where failure of the system is just too bad. And we said, well, if we're going to build a world financial operating system based on all this science that we carefully peer-reviewed, why don't we build it with formal methods? We said, okay, let's do that. So we hired a bunch of Haskell guys. We started writing formal specifications. Everybody thought we were crazy, and yet again we had to prime that pump, and we had to learn along the way. Few changes in project and product management, few delays, if you guys haven't noticed. But that was still fun, and we learned a lot. So then, in September of 2017, we launched Cardano, Byron, Eureka. And what did we launch? Well, if you're thinking about how to ride a bike, do you just jump on it, go down the tallest hill you can find, and say, good luck, everybody? No, you have training wheels. And similarly, if you're building something new, you try to build it in a controlled environment. So we launched Cardano in a federated environment. Cardano Foundation, IOHK, and Emergo control the network, similar to how the Ripple controls the Ripple network. And the point was to get liquidity. The point was to introduce the philosophy of the project. The point was to learn how to actually deploy a wallet, to do all those nuts and bolts things that you actually have to do if you have a product in market. Build those commercial relationships. So we did. And it broke. And we had to fix things. And we had to learn things along the way. And I have fond memories of Bitrix calling us on Christmas saying, we have a problem with our wallet. Can you help us out? And I said, oh, jolly. And I have fond memories of losing New Year's and anniversaries and other times kind of dealing with the consequences of a cryptocurrency in market. But little by little, we also built a community. When we first started, nobody really knew who we were. We were a small project, mostly based in Japan. And then somehow we started globalizing. We had fans in Cape Town, South Africa, sending us emails, people in Australia, people from Chile, people from Argentina, people from Canada. It was really amazing to see how quickly this project grew and spread. It went from something obscure to something that people actually paid attention to, which was really meaningful and really special. especially right here in Bulgaria. Our good friend Vasil, he started planting trees. A lot of people just started doing things. They got tattoos. They made their own t-shirts. In fact, I think the first Cardano t-shirt wasn't even made by us. It was made by a fan. We kept getting emailed and saying, do you have an official merchandise shop? We said no, and then people started creating them and selling swag. Good market opportunity for a while. And little by little, we started getting great feedback from our community. But you see, the project keeps going on, and now we're 2 years into it, and we've learned a lot along the way. We've built a lot along the way, and we're about to embrace a major series of changes. What remains on that 5-year roadmap when we started is the concept of decentralization, programmability, the concept of scalability, and the concept of basically governance. So we have to start actually tackling those 3 big problem areas. So what's happened? Where are we at today? That's the past. Where are we at today? Well, 2 days ago, we launched the networked testnet. This is the second in 3 testnets that are required to launch Shelly. And the network testnet is basically all about allowing people to actually connect to each other, communicate with each other, and start registering stake pools, delegating the stake pools. So basically testing all the mechanics of Cardano. All these protocols we wrote, those 40 papers, all this code we wrote, all these ideas we have, it's functionally the synthesis of them. And it allows, in a real-life environment, for people to begin playing with it and letting us know what we got right and what we didn't get so right. After that's done, which shouldn't take too long, we anticipate in November, we're going to launch what's called the incentivized testnet. David will talk about that a little bit in his presentation. But basically, if you're going to decentralize the system and hand it over to people, you need to build up a critical mass of people who are capable of running the system. So there's 2 ways to do this. You can just fork the network and say, good luck everybody, bye-bye. Or you can go ahead and build a safe sandbox, pay people in that sandbox, allow businesses and knowledge and domain expertise to build up within it, and at some point when you bubble over and get a critical threshold, you can pull it into the main system. And then that becomes Cardano's custodial set. So that's what we've decided to do. So come November, hopefully, but pretty good chance, we're going to go ahead and launch the incentivized testnet. And basically what we're going to do is take a snapshot of where we're at with Cardano, move it over, and if you have ADA at that period of time, you have ADA on this incentivized testnet. And it's just like Cardano. The only difference is, in that testnet, you can register a stake pool, you can delegate, you'll have all the interfaces for it, you can start actually staking. And the ADA that you earn there will be rolled over to the mainnet. It's a nice little sandbox. It's almost this sidechain philosophy we have, right? And so that'll run for a little while, kind of like a replicant, and at some point a Blade Runner will show up and kill it. And then we'll just have the mainnet. So next year, we'll probably pull it in Q1 of 2020. Hard to say exactly when, because it's not completely in our hands. That's the magic of decentralization. See, there's the software, there's the science, and that stuff is somewhat deterministic. Processes gradually get better, estimates gradually get better, you get more agile, you deliver more and more over time, and at some point you get pretty good at saying this is when something's done. But this is no longer just a technological project or a scientific project, it's a social project as well. So as a consequence, it's only done when we actually have hundreds, if not thousands, of stake pools operating together, competing together for your stake to be able to run Cardano as a network. And that's the point of the incentivized testnet. It's the beginning of that process, and people get paid to do it, so we'll see what happens. It's as much a social experiment like Bitcoin was as it is a technological tour de force. And should we accomplish that, that alone would be probably worth the time, effort, and money we spent. Because at the end of the day, if we get it right, the network will be 250 times more decentralized than Bitcoin currently is. It's pretty significant. And we don't spend the power of Switzerland. We only need about 10 kilowatts to run a global system that's fairly performant. That's a miracle of science. It's a miracle of good engineering, a lot of good work, lots of code, probably about 1 million lines at this point, and a lot of people who didn't sleep working really, really hard every week. But we're not going to stop there, you see, because we want the system to be useful. And it's not just good enough to have something that runs and is global scale and is getting more decentralized over time. The other parts of the Cardano roadmap have all been collected together to basically gradually build out towards that dream of a financial operating system, or at least a stub for it that potentially could achieve that over a long arc. So the next iteration is called Goguen. Later today you'll hear about Marlo from Simon Thompson, and we just got here from University of Wyoming. We were there last week where we had a great hackathon, and that's all about the smart contract. Okay, we've created our own smart contract programming language. And as a co-founder of Ethereum, that was kind of the thing that we started doing in 2013. Smart contracts by themselves aren't particularly interesting. And to be honest, they're misunderstood in the context of a broader commercial system. You see, transactions, they have properties about them, no matter if they live in a bank, an exchange, if it's you and your buddy shaking hands and some cash being transferred. There are actually 5 core elements to a transaction. And smart contracts, the commercial side, is only actually one of those 5 core elements. And we focus so much on that, but we tend to ignore the other 4. You see, with transactions, you move information and value. You have an asset. So that's the first component. And it amazes me that we have no ubiquitous blockchain agnostic standards for assets at the moment. We have ERC20 and ERC721, but why is the W3C or some other committee not defining assets? We kind of do in FPML and other things, but we haven't done it for an industry. And there's many types of assets. There's securities and commodities and property and money. There's all these various tokens that people have come up with, utility tokens, non-fungible tokens, and so forth. But that's one core part of a transaction. It carries an asset from one party to another. Second, how do you identify the parties within the system? You have one-to-one, so Alice to Bob, one to many, many to one, many to many. There's different transaction patterns. So do we have a canonical notion of identity in our system? How do we identify actors? The Bitcoin philosophy is pseudonymous. It just says there's an address here and an address here. It's very primitive. It doesn't map into the real world and how commerce actually works. You send money to Microsoft. You don't send money to an address. So we have the DID standard, for example, from the W3C, and a lot of progress has been made there, but we don't have the TLC we need. Then, did you just send money to somebody for the sake of sending money to somebody? You just say, here's $100? No. There's a commercial intent. There's a story. There's facts and circumstances. When you withdrew money from the ATM, where did you do it at? Did you do it in the park? Did you do it next to the Italian restaurant? There's context there, and we call this metadata. Transactions have metadata about them, which in many cases is just as meaningful, perhaps even more meaningful than the transaction itself. And currently that does not live in most blockchains. Thus, it is mutable, it's replaceable, it's malleable, and it can be spoofed to any particular agenda. And finally, the fourth thing is compliance. You see, transactions live within regulated environments, implicitly or explicitly. If I hand you money here in Bulgaria, that transaction is a Bulgarian transaction, subject to Bulgarian law. If I go ahead and send a transaction from Bulgaria to Germany, it's now subject to the laws of 2 countries. If it's a one-to-many transaction, I could create conceivably a transaction where I go from Bulgaria to every country in the world. And therefore, we're now globally regulated. Every country has a say on that transaction. It's actually cheap to do that too. Just create an address with an owner in each country. It's a little bit of coordination, but the system wouldn't care. So regulation is also important. Now with the new FATF regulations, this travel rule idea, US Treasury Department talking about it, it's becoming increasingly more important in our industry. And if these systems are to be useful, we do have to have an opinion. How will they work from a regulated reality? And it's also contextual to the actors, the story behind the transaction, the types of assets that we're dealing with. So it's a very complicated interdependent puzzle. So for the last few years, because of Ethereum, we've focused a lot of attention on the smart contract. Those are the terms and conditions. That's how the transaction executes. But we've ignored the other 4 parts of the story: the assets, the metadata, the identity, the regulation, and so forth. So for Cardano to be useful and become a real financial operating system, if I was to plausibly go to Ethiopia and say, I know you guys don't have a stock market, Why don't you just use Cardano and build it on top of that? I need, as a system architect, to make provisions for those 5 areas. Part of the research we've done with Marlowe and with Plutus has gone beyond how do we have gas accounting and how do you write code and how do you build a DApp. It's also looking holistically around everything. It's saying, how do we embed metadata? How do we build special purpose domain-specific languages for certain types of assets? How do we deal with things outside of the system, whether that be off-chain code or oracles and so forth? This is a holistic view that's required. And all throughout 2020, we'll be gradually, slowly, but surely adding features and functionality into Cardano that will start thinking around those 5 parts of a transaction. So when you send something on our network, it can make it look like a Bitcoin-style push transaction circa January 3rd, 2009, and you can go all the way to a modern Cardano transaction and embed all kinds of interesting data inside that thing and enjoy the power of that. So if we do that, I have a firm belief Cardano will be the most useful cryptocurrency on market. But are we done? No, because we need to scale. We need to go beyond just a few hundred TPS. We need to go beyond just the ability to send a few thousand transactions an hour. We need to be able to move to a world where Cardano could service realistically millions to billions of people over an arc of time. Because if we're successful, we'll become victims of our own success, as everybody who's written a viral app knows. So how do we do that? Well, we have a beautiful protocol called Ouroboros that we spent years and years and years developing, starting from very, very bedrock first principles. What is a blockchain? Then we asked what could make potentially a good scalable approach. Okay, so with consensus in a cryptocurrency, you kind of have 3 things you have to do. 1, you have to pick somebody who's in charge for a period of time. Bitcoin does this through the mining process. It's a competitive process, but then somebody shows up and says, I have come up with a proof. And they say, yes, it's real. You're allowed to make a block. Go commit your block. Second, you have to advance the state of the system. So people propose to do things. They send transactions to each other. And they all kind of aggregate into a memory pool. All these proposals. And then somebody goes and hoovers them up, puts them all into a little package called a block, sticks it on the blockchain. Okay? So first, somebody has to get the right to do that. Second, somebody has to do that. Third, the network has to accept it. So analogously, imagine a poker game. You pick a dealer. Then the dealer deals the cards. You receive the cards, and then you look at them, and you try to validate, is this a fair dealing? If I get 5 aces, I'd say, no, there should only be 4 in the deck, right? Well, similarly, if you have a double spend transaction, you'd say, no, this doesn't seem to be right. It's not a valid block. So these are the core 3 things. Bitcoin spends almost all of its time, effort, money, and complexity on the first, picking the leader. Proof of stake just gets rid of that completely. It says, we're just going to have a lottery proportional to how much you have, and we'll just pick a winner, and that person will then do the other 2. And as a consequence, the system implicitly feels like it can scale. Second, because you're explicitly picking leaders and you know that these leaders exist, do all kinds of cool things, from routing to basically creating multiple committees of leaders and so forth. So implicitly, when we were building Ouroboros, from the very beginning, we knew that if we could solve deep theoretical problems with the proof of stake approach, from incentives problems to problems like nothing at stake and long range attacks and so forth, that we probably could scale a system to millions to billions of people over time. But to solve those problems was quite a bit of difficulty. We wrote Ouroboros Classic, Ouroboros Pros, Ouroboros Genesis, Ouroboros BFT, Ouroboros Caceros is coming out, Ouroboros Hydra, Ouroboros Chronos, and so forth. So we wrote a lot of papers, and these papers went to very rigorous academic conferences, and we had some great debates along the way. Crypto, CCS, I think NDSS, we were in Eurocrypt, and so forth. And these are very difficult conferences to go to. Generally speaking, they only accept 10 to 20% of the papers submitted to them, and that's among domain experts. So these are papers submitted by academics at major universities. And we sure as hell had to go through the referee process where people said, boy, we don't like what you've done, or what's this all about, or this proof isn't right, or are you really sure about this particular claim? And little by little, the security of the system got better. We went from kind of a toy synchronized system that really wouldn't work in practice to a fully semi-synchronous system with adaptive security. We gained the ability to bootstrap from Genesis. We gained the ability soon to recover from dishonest majority. And the holy grail, scalability. That's coming with Ouroboros Hydra. And that publication is nearly done. So we have a skunk works within IOHK we're putting together specifically for that. Sometime during 2020, we'll be able to take what we're just about to publish, Ouroboros Hydra, and roll it into our system. So decentralization, useful smart contracts, and thinking about the transaction, and shortly thereafter, Hail Hydra, for all of you fans. We'll go ahead and roll that in. And that's going to be all about basically building a system where we take advantage of the design, take advantage of stake pools, take advantage of the fact that we know leaders, and we'll be able to accelerate the system beyond most, if not all, cryptocurrencies currently in market and coming onto market. And not to be outdone, there's actually a completely orthogonal scaling approach that we can use, that we can roll in beyond 2020 if we need to do that. But it's not even clear if we actually need to do that or not. So that's a partial solution, but there's still a lot of research that needs to be done. Still need to think about how do we shard the network side of things, because if you have a high performance system with hundreds of thousands of transactions per second, if you're getting all of it, the only way you can stay up to date with it is if you have a fiber optic cable and you're right next to the internet, right? If you're on a Wi-Fi or a little 4G connection, you wouldn't be able to. So there's a lot to think about there. Second, there's the data sharding problem of we'll become victims of our own success. If you save everything forever, eventually it goes from gigabytes to terabytes to petabytes to exabytes to yottabytes, and who can possess that chain? No one. So you have to think very carefully about what you keep, what you throw away, and how do you compress things. And we've made some innovations there with NEPA-POWs and our sidechains protocols and so forth, but it's an active area of research. That said, I think next year we'll be able to make one of the most meaningful in the entire industry's contributions to scalability. And for the most part, mission accomplished there. But you see, none of this matters if I'm in charge. None of this really matters if every day you require IOHK to show up and work hard and be brilliant and pay for everything and build everything, or Emergo or some other entity. The point of these systems ultimately are to be decentralized, which brings us to the final part of the roadmap for 2020. We have to find a way to turn over the system, not just in terms of operation, but in terms of where it goes, the payments of things, the philosophy of things, the direction. Should we increase the privacy of transactions and start chasing Zcash? Should we make ourselves immune to quantum computers now that Google has made great progress there? There's a lot of philosophical questions, technological questions, roadmap questions that will extend far beyond 2020. And the point of a cryptocurrency is that somehow, some way, the culture, the technology, the processes of that system align towards putting you in charge, not me. These are global systems. They don't have ethnicities, they don't have cultures behind them, they don't have a canonical language behind them. They belong to you just as much as they belong to me. For example, who's in charge of Bitcoin? Can you point to a single person, actor, entity? Is there any one person in the Bitcoin ecosystem that you can get rid of that then suddenly Bitcoin would fail? Well, the answer is no, because we've gotten rid of all of them at least once or twice. The Mt. Goxes have failed. All of these entities have failed. Mining pools have collapsed. Cabals and conspiracies have formed, like the Bitcoin Foundation. And despite all these attempts to co-opt, coerce, or take over, still here, still going strong, and nobody's in charge. But unfortunately, it's not really competitive. It doesn't move very quickly. The very same things that incubate the system and make it resilient also prevent the system from upgrading. For example, the block size debate, or changing the signature scheme, or adding more programmability to the ledger. So the great challenge for us is, how do we keep the good and get rid of the bad? The good of being able to take a heavy hit, lose anyone, doesn't matter who. The good of having a country ban us, but yet still be here tomorrow and still be just as valuable, just as liquid, and just as strong. But not the bad of now being frozen in stone, unable to move, unable to upgrade, unable to update. Furthermore, no one knows how to participate. For example, how do you actually influence the Bitcoin ecosystem as a developer, or just as an average person sitting here? Where do you go? Reddit, Bitcoin Talk, Twitter, GitHub? Like, who do you talk to? You know, what's your entry point if you want to make meaningful contributions? The whole reason the altcoin space exists, and we have more than 1,000 cryptocurrencies, isn't just because people like printing their own money. It's because people want to innovate. People have cool, interesting ideas. They've legitimately done things that are extraordinary. And they felt disenfranchised and unable to share those ideas, those contributions, those values with the Bitcoin ecosystem. So they had to go elsewhere and do the crazy thing of building their own network, which is a really difficult endeavor. So the greatest challenge for us as a project, because the other ones, the interoperability challenges, the scalability challenges, they'll either be solved via consensus or through science, and it's an inevitable thing. The greatest challenge is, how do we build a great governance system for Cardano? How do we put you guys in charge? How do we get high participation? This is an equivalent problem to, how do you build a great government? You know, we have this problem called rational ignorance. That is, the value of knowing something is less than the time and commitment it takes to know it. Yes, I could sit down and spend a lot of time and master the intricacies of string theory. And what's that going to do for me? Not a lot. So I think I'm going to stay ignorant to the intricacies of string theory. And we could look at the American healthcare system the same way. All of you could spend a heck of a lot of time, read lots of books, and master American healthcare. What's that going to do for you? Is that worth the time you invested, the many books you'd have to read, the many efforts you'd have to have, even if you live in America, even if you can vote in America, just one vote. And regardless of how much you invest on being a good, well-informed citizen, your vote counts the same as the person who didn't do it. So is it rational to invest that much time, effort, money to learning and mastering these things? If you're an older pensioner and you have nothing better to do, well, maybe. It's why the disproportionately large amount of people over the age of 50 vote compared to people under the age of 25. Well, here's the problem. How do I turn over the system to the general community, the general public, and expect them to make difficult decisions, philosophical decisions? Should we ever be able to reverse a transaction? Should your funds ever be frozen? Should we ever have auditable backdoors in the system? Should we ever prune the ledger and show what do we throw away and what do we keep and who gets to decide that? When people have no incentive to think about these particular problems, perhaps beyond just the value of a token. So it's a big challenge, and we've written some papers on it. First, there's the nuts and bolts of consent, the voting systems that you use. And we firmly believe that liquid democracy is a good starting approach. It kind of takes all the best of what we've learned from delegative democracy and direct democracy, and it's a much more fluid system, and there's some great theory behind it and good political science behind it and good papers behind it. And it turns out it's actually quite easy to build these types of systems in a blockchain setting. Great, so we have some voting mechanics, but there's still a question of what are we going to vote on? I think it was Stalin who said, I don't care who's on the ballot, I care who gets to decide who's on the ballot. Right? So who cares who you can vote for? What matters much more is what is the process upon which we get things to vote on, and who gets to decide that. So there's a lot of open questions that still have to be resolved, and they'll go well beyond 2020. But for IOHK's purpose, we have to build a system where there will be funds available beyond 2020 for people to think about these types of problems. So the first thing we're going to implement next year, after we get through Gauguin and Basho and we get through the remainder of Shelley, is a treasury system. These systems print money for a living, and right now they give all the money to the people who maintain the ledger. So instead of giving it all there, we'll give a chunk of it to basically a decentralized account. Then people can issue ballots against it for funding proposals. Dash did this, they innovated this. It's a good idea, and it's an idea that we'll bring into Cardano, which means now you actually can participate. For example, there's a great machine outside where you can buy buy coffee with ADA. Pretty cool. Well, what if that company went to Emergo and they said, you know, we might be able to get every vending machine in Japan to be able to have this capability. And then suddenly you can buy soda in Japan, or let's say here in Bulgaria, with ADA. Would that be worth something to the Cardano ecosystem and the community? And instead of a traditional VC model, because maybe there's not a strong business case for this, at least in the deployment of it, maybe it's a strong community model. They could submit a fundraising ballot to you, the entire ADA ecosystem, the whole world, and say, is this a good use of our money? That's one example. The same for ATMs, the same for evangelism. What if there's somebody in Nigeria who wants to run a community meetup and he can bring thousands of people together? Is that a good use of funds? Do you want a central committee deciding these things? Now, in this type of a system, everybody can just submit a ballot. And over time, and through good marketing and through good evangelism, it'll sort its way out. That's a good starting point. Second, we need to deploy what's called an improvement proposal process. It turns out there is a bit more structure to the evolution of Bitcoin than I was letting on. If you want to upgrade Bitcoin, there is a way to do it. You file what's called a BIP. And if you want to upgrade Ethereum, there is a way to do it. You file what's called an IP. And so, along those lines, we should have the Cardano improvement proposal process, a CIP, a CIP. So working with the Cardano Foundation this year and next year, we'll be developing a reference CIP process and teaching people how to utilize it. And as we get to the second half of 2020, more and more of our development processes will start dogfooding, start utilizing that CIP process. This is the very first step in being able to start getting consent for upgrades to the system. Because then everybody will know how to propose an update and upgrade to the system. And then we can use the very same voting mechanics that we've constructed for ballots now on the CIP process. Now, if this works, then you can actually poll the entire network, the people who actually use the product, and say, where do you want to go? Should we be private? Should we not be private? Should we use this algorithm over this algorithm? There's some democracy there. These are tools, but it still remains to be seen what incentives are required to drive participation, use of these tools, incentives for these tools. And what's really cool about this problem is it's a broader problem than just Cardano. It's not just a problem for even the blockchain industry. It's the problem for everything, where you have a collective good that lots of people like to have and consume, but no one person has strong incentives to maintain. It's a tragedy of commons issue. So, turns out that people study this. They come up with all kinds of really interesting incentives models. And it turns out that potentially the same way you could eventually start a business to run a stake pool and maintain the Cardano ledger, you may end up becoming a professional politician for the Cardano ecosystem one day. Get paid just to be an expert. We have those people in the Bitcoin space, implicitly. Has anyone heard of Andreas Antonopoulos? He's basically a professional Bitcoin expert. He has no job. No one really pays him. He doesn't work for a company. He just goes around from conferences to conferences, writes books, has a Twitter presence, and has an opinion on how Bitcoin should be, where Bitcoin should go. We could end up creating a class of people incentivized by the very network itself who not work for a company, but work for the blockchain. And all their job is to think about these things, participate in these things. And if you have a delegative democracy system like liquid democracy, not only can they think about it, they'd actually have voting power. So effectively, we might even create our own parliament that basically governs these systems and runs these systems meritocratically. How big it is, I don't know. How much power will it have? Who knows? How much profit would you make for participating in it? Well, I don't know either. The system decides. You decide. The users decide. It's a pretty cool concept of decentralized governance, and here's what's so cool about it and why this space is so very interesting to me. You see, if all we accomplished was building a better bank, or a better exchange, or a better stock market, or clipping off a penny from a transaction that people send, or making wire transfers cheap, this would be an evolution, and I guess it would make some people rich, and we'd be able to go home and say, yes, I did something. But it's not meaningful. The reason why we're here, this industry exists, is because the world is changing. The philosophy of the world is changing. The way the governments work are changing due to the pressures of instantaneous, instant availability of information from the internet, the instantaneous flow of value from the internet, and from globalization. You see, we no longer live in these little silos and hierarchies with standard narrative fictions that have existed for long periods of time. The people in Ethiopia can have just as much impact on the world as the people in the United States now, and have the same access to information as the people in the world. So this is changing everything. It's creating friction. It's why we have Brexit, and why we have Trump, and it's why we have financial collapses and all of these things. So The point of our industry is we're providing a toolbox and a collection of visions of where we can take the world, where we can collectively decide on how to solve problems, whether they be environmental problems, whether they be problems of governance and wars, or problems of resource allocations, without saying that there's some central country in charge, like China or the United States, or without building some sort of giant meta-government that basically gets rid of the nation state. That's the magic of the blockchain industry. We, in a completely decentralized, libertarian, private way, are having conversations about reinventing money and consent and property rights and the very structure of the world. The point of Cardano has been to be a model for how to do this. Focus on process over people, use the scientific method. If you're going to build these things and people have to live with them for a very long period of time, you should probably build them well and build them to last, like the castles of old, which is why we use formal methods, and think a lot about how to replace yourself. You see, Satoshi did one thing exceedingly well. Did a lot of things, but one thing exceedingly well. He figured out how to fire himself quickly. He followed the Paul Helmuth method of development. Told you what he was going to do, did it, and told you what he did and left. So here's the Bitcoin white paper, wrote all the code, launched it, got a whole bunch of people around it, told them what it all meant, disappeared, never to be seen again. That's how we should aspire to run these types of ecosystems. And what we've done in these 5 years, all this work, all this effort, is basically build a model for that. And if we're successful, even if IOHK disappeared, Cardano would be stronger than ever. It's a beautiful thing, and it's a dream I hope for one day. We'd still like to be there and participate, but we'd just be one of many voices, and we'd no longer be in a position where we decide where to go and what to do. You'd decide that. So why are we here in Bulgaria? In closing, we could have gone anywhere in the world. We have fans everywhere. We could have been in Chile, we could have been in Buenos Aires, we could have been in Berlin. Big markets. We could have had giant stage with red carpets and thousands of people and light shows and things like that, like certain other cryptocurrencies do. What I really wanted to drive home to everybody in this ecosystem is that this is not something marked by events, dates, times. You know, this is not something where we say, oh, well, once we get to this stage, then we've made it. Just like marriages or learning or anything else, it's a spectrum, it's a process. You see, when in the life of a tree do you look at that and say, this was the day it truly became a tree? This is the day the tree was successful. For this tree, what day is it going to be? Is it today? Is it tomorrow? Next day? A week from now? A month from now? Then it's finally a true tree. It's here to stay. There's not one. It just grows a little by little every single day. And as long as the inputs are there, it'll keep growing. It'll keep getting stronger. And the man who understood this the best in our entire ecosystem was Vassal. There's an old quote, "A society grows strong when old men plant trees they know they shall never sit in the shade of." And so the things that we build here today, the ideas and thoughts that we have here today, are not about today. They're about 2050. They're about 2100. If you've ever had the opportunity to meet people like Vint Cerf, one of the creators of the internet, he just made decisions about TCP/IP, never even imagining that it would grow to the scale and prominence that it had today. And so if we're going to rewrite the DNA of society, we're going to change the way your money works, your property works, we really should treat it more like a tree than a series of events. We should really think about what are the inputs, the soil, the environment it needs to live in, and how do we take care of it and be custodians of it as long as we can, and then when we can't do it, make provisions that someone else can take care of it. And if we get it right, we'll wake up one day and instead of seeing a tree, we'll see a forest. And that's there to last. So 2 years now, a lot of work, getting a little older, got the white hair and the beard now. And I'll probably get a lot older and eventually I'll lose enough hair that I'll shave my head. It's getting pretty popular in our space. And I can't wait for 3 years and 4 years. And it'll be a day I wake up and it's 20 years and 30 years. But I'll know I've gotten it right when, regardless if I'm around, the party's still being held and it keeps getting bigger and bigger. So thank you all for coming. It's going to be a lovely day. We're going to have a lot of fun, and let's look forward to the future. Cheers.